This video deals with the topic of SCR or Silicon Controlled Rectifier, which is an unidirectional semiconductor device made of silicon. This device is the solid state equivalent of a thyrotron, and hence the other name given to SCR is thyristor or thyroid transistor. In fact, SCR, that is the silicon control rectifier, is a trade name given to the thyristor by General Electric Company. Basically, SCR is a 4-layer, 3 junctions PNPN semiconductor switching device. It has 3 terminal, anode, cathode and a gate. The symbolic representation is shown in the right hand side. It has 3 junctions J1, J2 and J3. The gate terminal, that is the G denoted as G, is attached to the P layer nearer to the cathode K terminal. Now, the static characteristics of a SCR. Here you can see the SCR has mainly 3 regions of working, or 3 modes in which an SCR works. The first is the reverse blocking mode. The second is the forward blocking mode, and the third is the forward conduction mode, which is the on state of an SCR. So, the static characteristics has 3 modes of operation. Now we start with the reverse blocking mode. Here in the static characteristics, we have to keep in mind that the gate is always open, that is, we have not provided any supply to the gate terminal. Now, in triggering method, the SCR static characteristics, what we do is, in the reverse blocking mode, we put the cathode K as positive with respect to anode A. So what happens when the cathode K is positive with respect to anode A, keeping G open, is G3 and J3 and J1 are reverse biased and J2 is only forward biased. As J3 and J1 are reversed biased, a depletion region will be formed across the junctions J1 and J3, and there will be very minimum current flowing through it due to the minority carriers, which is called the reverse leakage current. Here in the diagram you can see a very minimum current flowing through the SCR due to the reverse leakage current or the flow of minority carriers. And this mode is called the reverse blocking mode. It is blocked, it is in off state because of the reversed bias of junction J1 and J3. But after a certain point, say VBR, which is the breakdown voltage of the SCR, if we keep on increasing the positive voltage across the cathode at a certain voltage, which is the VBR, the reverse breakdown voltage, the junctions J1 and J3 will go through breakdown, which is the avalanche breakdown, and due to this breakdown a huge amount of current will start flowing through the SCR, and you can see that the flow of current has suddenly increased from P towards Q, a sharp increase in current. This is the all about the reverse blocking mode of SCR. Now comes the forward blocking mode. In forward blocking mode, what we do is keep the cathode K negative with respect to anode. When the cathode K is negative with respect to anode, what happens is junction J2 is reversed bias, whereas junction J1 and J3 are now forward biased. Now, due to junction J2 being reversed bias and a depletion region being formed there, a large current won't flow through the SCR because J2 will block it. The reverse bias in the junction J2 will block it. So, a very minimum current is flowing through the SCR, which is the forward leakage current. And this mode, that is from 0 to M, is the forward blocking mode. Forward blocking mode. Now what happens is when we keep on increasing the voltage, negative voltage across K or the positive voltage across the anode, then what happens is at a certain stage again the junction J2 will go through breakdown, that is the avalanche breakdown, and there will be a sharp increase in current with a decrease in or a drop in voltage. Now here the point where the breakdown occurs in forward blocking mode is the VBO, breakover voltage. And what happens is there is a voltage drop which is shown by the curve M to N, and at point N there will be a sharp increase in current, which is the forward conduction mode, because J2 junction has gone through breakdown and there will be a huge flow of current. This is the forward conduction mode. Now we have to keep in mind in both the cases that we should not keep on increasing voltage beyond this VBO and VBR, then there will be heating, a temperature increase in the SCR which can burn it out. Now in the forward conduction mode, two things are to be kept in mind, that is the latching current and the holding current. These two terms are very important in consideration with our SCR. What is this latching current? Latching current is usually denoted by I suffix L, and holding current is usually denoted by I suffix H. Now, latching current of forward biased SCR is the minimum current which the anode current must attain to continue to remain in forward conduction mode when there is no voltage, there is no gate current. Again I am repeating, latching current is the minimum amount of current that the anode current should have in order to maintain it in the forward conduction mode. Now what is holding current, IH? Holding current, on the other hand, of SCR or a thyristor is that minimum value of current below which anode current must fall to come to off state. Even if our anode current is lower than latching current, it won't go off, but it won't be in forward conduction mode. But if it goes below IH, that is the holding current, it will go to off state. And holding current is always less than the latching current. Now moving forward, there are some methods how we turn on the SCR. The first method that already has been described is the forward voltage triggering that is being mentioned to you while describing the static characteristics of SCR. That is, whenever anode is made positive with respect to cathode, junction J2 will be reversed biased and J1 and J3 are forward biased. But as we keep on going on increasing the anode voltage, positive voltage across anode, then what will happen at a certain point, J2 will be in breakdown due to avalanche breakdown, and there will be huge amount of current flowing through the SCR. This is one of the methods of turning on the SCR, as we have already discussed. The second method, which is the widely used method, is the gate triggering method. Till now, if we notice that, and I have mentioned again and again, we haven't provided any supply to our gate. But now, when we are applying a positive voltage to the gate, then what will happen is J2 will have a huge flow of electrons across its junction, which will make it go to breakdown much before VBO. Here in this diagram you can see, as we have provided Ig1, that is a gate current flowing through our gate through the SCR, then what is happening is the SCR is going through breakdown, or the junction J2 is going through breakdown much before VBO, at almost at V1. Again, when we keep on increasing Ig, that is the gate current, we see V2 is again, the breakdown occurs at V2, which is much lesser than V1. Again, when we keep on increasing Ig, that is we keep it as 3, the voltage at which breakdown occurs is at V3. Now V3 is lesser than V2 and lesser than V1, but Ig3 is greater than Ig2 and greater than Ig1. That is, as we keep on increasing the gate current, the SCR goes into forward conduction mode, or the junction J2 goes into breakdown much before VBO, due to a large amount of electrons being accumulated in the junction J2 due to a positive voltage at G. Now the third method of SCR turning on is the dV/dt triggering. Now what is dV/dt? It's a simple method. See, whenever we are providing the SCR is in forward bias mode, what happens is J2 is in depletion, J2 is in reverse bias mode, and a depletion layer is formed across J2, which acts as a capacitance, and the capacitance here is Cj. So a charging current IC will be produced here, which is IC is equal to dq by dt, and now q can also be written as Cj, that is the capacitance across the depletion layer and the voltage applied to it. So this can be written as Cj dVA dt plus VA d Cg dt. Now junction capacitance is almost constant. If junction capacitance Cj is constant, then the rate of change of Cj with respect to time is 0. So the next second term vanishes, and what we have is the charging current IC. There will be a current IC which depends on Cj dVA dt. So as we go on increasing the applied voltage, or keep on changing the applied voltage with respect to time, the current through the SCR will keep on increasing. Now the fourth or the last method is the light triggering method, and the SCRs which are turned on using the light triggering method, or when we make light exposed or fall on the SCR, are also called LASCR, that is light triggering silicon controlled rectifier, or you can say light triggering thyristor, which are nowadays used in high voltage DC transmission systems. And what happens is, whenever we make a light fall into the window of P at a certain wavelength, electrons will be induced and the SCR will go into forward conduction mode. So, but then, having mentioned all the four methods of triggering of SCR, let me again tell you the most widely used is the gate triggering method. So class, thank you for now. In the next class, we will study about the two transistor analogy of SCR.